This morning, there was a magnitude 7.9 earthquake in the just south of Kodiak Island. The location of the event puts it right on the Pacific Plate before the subduction zone where the Pacific Plate goes underneath Alaska. The plate consists of the ocean crust and the lithosphere. So it's the crust and lithosphere that are sliding over the asthenosphere that produce these plate motions. Normally we expect earthquakes at the intersection of different continental and ocean plates. And this one is an inter-ocean earthquake. It's fairly unexpected. So also in this area, since the Pacific Plate is converging on Alaska, you'd expect it to be a thrust mechanism. But this was a right lateral strike-slip vertical fault. You can see that from the tensor motion analysis of the first waves. So it's really unusual, again, to see something of this magnitude in the middle of a plate. It would be like having a magnitude 7.9 in New York State. You know, it's just not normal. It is a concern when you have a shake of this magnitude when you're a resident along the coast of Alaska, either along the Aleutians or Kodiak Island itself. So the shaking can, not only does the crust of the earth rise or fall, which produces tsunamis, but even worse is large sections of sediment can slump off of the Alaska shelf. And when that happens, you're essentially dropping the ocean floor. That could be like 30 meters. And so you're pulling the ocean basin down. And so that draws the water off from the coast. Consequently, after a period of about 20 minutes, that depression fills again and the water sloshes up on the shoreline. It's known as a tsunami. In Alaska, because of the fjords, the wash can go up to 700 feet in elevation. So it's common if you're working in Alaska and you're on the shoreline during an event, if you're not next to a large mountain, you want to get in a boat if you see the shoreline retreating and get offshore as fast as possible, because you are not going to be able to climb anything high enough to get you out of that swash zone. So I worked in Alaska myself, Kodiak Island in particular, and we were always feeling earthquakes. They're really common. There was, we had this big one today, but there were 7 more in that area today already. So it's a common area for seismic motion and earthquake events. So the thing to do, when we ever felt an earthquake, even at night, we'd jump out of our sleeping bags, go right to the shoreline, put a stake in the ground right next to where the water is, and we watch it. Just say, okay, is that going down? And if it goes down, in most of the places we worked, we would jump in our inflatable boats and head offshore. You don't have to go too far. Probably 5 kilometers would get you out of the tsunami region. So another thing about this earthquake, it was the lithosphere of the ocean there is about 100 kilometers thick. And the event occurred at 35 kilometers of depth. And again, it's a strike-slip, right lateral strike-slip motion. And so the only thing that can explain a motion like that is that parts of the Pacific lithosphere are sticking where it goes underneath, where it subducts underneath Alaska. And so it's starting to rip. So parts are sliding and parts are being held back. And the parts that are being held back would be the part going under Anchorage, where we had the biggest earthquake in Alaska in our recorded history. It was a magnitude 9.4 and devastated that area. So that almost makes sense that the plate is sticking under the Fairbanks area and sliding easier under the Kodiak area. So what this means is that there's stress being built up under Anchorage, which will again result in another mega fault. Now Kodiak itself hasn't had an earthquake since 1900, a subduction zone earthquake. So it's also way overdue. And the fact that the plate is moving, it's about 230 kilometers of the plate slipped forward this morning. That also predicts, we would predict that Kodiak is due for a mega fault in the near future. So this is a tensor first motion map of the earthquake, so this will be the event. And this right here is where there's compression, and here's where there's rarefaction. And the only way to explain that is a fault moving this way and that way. So that's a right lateral strike slip. You can also do it in a east-west, but we're not going to expect any east-west motions in this area. Everything's moving to the north. So this gives us a good idea. This is a classic motion map of a strike slip. Alaska is a really exciting place to work. It's an area of lithosphere that's being condensed like a nutcracker between the Russian craton and North American craton. So these two major areas are coming together, and Alaska's in the middle. And you can see all of the faulting and seismic activity that's going on. The location of the fault that we just experienced is right about here. And again, you can see the vector motions of the plate is 6 centimeters a year, moving toward the north. So, working along here, you can expect mega faults up here. They're mainly strike slip faults, but they can be on the order of magnitude of the San Andreas type fault. San Andreas, in fact, is a strike slip fault between the Pacific and North America. So there's a lot of adjustment being done up here.